So, welcome to the lecture 4 of this module 1, that is a crop growth and development phases for input management. So, as we discussed the introductory classes about the crops, crop classifications, crop ecosystems. So, when you progress towards the modeling, so we need to know the particularly we are doing the crop modeling simulations for the input management, and of course, to know the effect of weather parameters. So, knowing the crop growth and development is very important for this input management point of view. If you know the growth and development, then that gives understanding the particularly what stage is very critical stages we will go for the input management, means the water and nutrients, and of course, the plant protection measures. Now, as this is very crop growth stage specific, if you apply the nutrients at the proper time and the proper dose, definitely proper time, proper amount, then we will be able to maintain the productions. So, let us come to this. We should know what are the crop growth and development. So, this gives a if you see the growth, that gives a you see the what is the difference of growth and development. Growth and development are the parallel process in the crop. Their growth means we can quantify the increase in size, increase in weight, that is a plant biomass or the plant height, plant leaf area. So, that we can quantify over the time. So, how much maybe gram per meter square or the kg per hectare, that is the crop growth. If you look at development, development happens with the growth. If growth comes, there is development. Development means this is a qualitative term. We do not express as a quantitatively, but that talks about the physiological appearance in the crop. If you see the crops, that is a leaf emergence, this is a developmental phase. That is a flower has come up, flowering has started, a development. Fruiting, that is a development. A crop has entered to the maturity phase, a development. So, these are the developmental phases which we do not measure as a quantitative term, rather we see as a qualitative term, we can visualize this. Development can be visualized. You can see there is a leaf appearance, there is a branch appearance, there is a flower appearance, there is a fruit appearance, and the crop is going to fruit is going to mature. So, these are the visual appearances, and that you can say as a quality term, which you do not measure as measure this one, but you can visualize. But this growth and development, these are the the processes, they go on parallel. The development happens, the proper growth, then you can go for development, and there is a development is the economic part comes, which is a proper growth phase of the crop. So, this is what I will be discussing this lecture. So, how to measure the growth, what is the growth, and how the growth, knowing the growth and developmental phases, that helps particularly for the input management, either the water and nutrients. So, what are the factors influencing the growth and development? Already you have discussed this factor, the crop factors, that same as the growth and development. So, much not I do not think it require very much large discussion here. This is the factors like crop species, as discussed earlier, the growth and development crop, the growth habit of the, as a plant is one of the factors, this is a plant genetic potential. So, with particular plants, the external factors that mainly influence the growth and development, these are the light, that is a solar radiations that influence the photosynthesis and the flowering, temperature, because the radiation that leads to temperature, and temperature affect all the developmental phases as we are discussing, that is germinations and the appearance of flowering, the maturity, that depends upon the temperature. So, also that indicates the growth rate, how much growth can happen regulated by temperature. Mostly growth rate. So, that is a temperature, so it is the solar radiation that leads to growth rate, how much growth can happen, that depends upon the radiation, because photosynthesis, radiation leads to photosynthesis and growth rate, and of course, because temperature comes because of the solar radiation, that also somehow links to the growth rate, and mainly the temperature influence the growth durations. So, the water, then the water is essential for the nutrient transport, and the transpiration, where transpiration is a productive loss of water. The plant must transpire, because through transpiration the plant can regulate the canopy temperature, which is because if there is a climate change, high temperature, but if you keep on irrigating, you keep the soil moisture in proper optimum conditions, the crop can survive the high temperature, because that regulates own temperature. So the depends upon the water, because the growth water availability that leads to turgidity and nutrient transport. Then this also this the abiotic factor like nutrients required for the growth and development. So we are not going to discuss about what are the nutrients essential. There are around 17 essential elements are there for the crop growth and development. We know there is a macronutrients, micronutrients, particularly we have the carbon, hydrogen, oxygen. So these are the and the nitrogen, phosphorus, potash, calcium, magnesium, sulfur. These are the 9 nutrients, and among these 9, carbon, hydrogen, oxygen we do not supply to the crop, because no crop gets it through the nature from the atmosphere, carbon, hydrogen, oxygen. And if you see the plant parts, if you go for the dry the plant parts and to analyze the elemental composition of the plant parts, the maximum percentage comes from carbon, hydrogen, oxygen. Carbon accounts for the 40% of the dry biomass. If you see, oxygen 40% and 10% goes for the hydrogen. This 90% of carbon, hydrogen, oxygen. The rest 10% that remains of a nutrient. Among the 10% you can find nitrogen, phosphorus, potash, calcium, magnesium, sulfur. These are the macronutrients. NPK is the primary nutrients, calcium, magnesium, sulfur is the secondary nutrients. They have the major portions, and you have the rest 8 is your the micronutrients, and that is your the you can say your the iron, manganese, zinc, copper, boron, molybdenum, chlorine, nickel. So these are the micronutrients are there. So because these nutrients are essential for the crop growth, because they are essentiality, they are essential for the crop growth and development. So that is what this influence, because their presence is essential, because you see essentiality criteria, because in absence of a particular elements, the crop cannot complete its life cycle. Then you say that nutrient is essential. Based upon that, we have the 17 essential elements. So these nutrients, because when you go for the particularly for the modeling exercise, we have not developed so much to go for the micronutrients. You go focus on the major nutrients, particularly nitrogen, phosphorus and potash. We go for the management of these 3 nutrients NPK, because that leads to the growth of the crops, and to calcium, magnesium, sulfur. The other nutrients, they do not increase the biomass, but the micronutrients, they influence the quality of the products through the micronutrients. So these are the abiotic factors. You say the weather parameters or the nutrient managements, and the biotic factors are there for that influence the growth and development, particularly pests and diseases. So models are there to take care of the pest and diseases. So there is a pest and disease are there. So the model also simulate the effect of the pest and diseases, and how to take care of the pest and diseases to avoid any yield reductions. Then proper management of this that can have the maximize the production. So these are the measure the phases of the crop growth and development, particularly from the germination and the seedling establishment phases, from seed sowing to emergence and the early root shoot formation. So initial phases for this period, because that decides the crop stand, because farmers, you see the farmers spend huge money initial land preparations and where the sowing of the seeds, and if there is any loss or the germination failure, if the germination failure, there is a huge loss to the farmer's economy, almost more than 50% he has invested land preparation, seed sowing, fertilizers. So it is very essential to see that a proper land preparation is there, and the seed quality and soil moisture, seed bed preparation, soil moisture should be enough for the proper germinations. Not only germinations, proper stand establishment. After germination, this should also facilitate proper root development, so that the seedling can establish. So this phase is very critical and very crucial from the farmer's economic point of view. There should be proper conditions for the seed sowing, seedbed preparation, seed sowing and the established germination, establishment of this. So, that what the input focus, the quality of the seeds is very important. So, that proper germination, seed treatment, proper sowing depth and the initial soil moisture, that influence the stand establishment. Then after that, then comes the vegetative phase. So, where the once the crop is established, then we have the active leaf, stem and the root formations, that is a canopy development, and here the focus is your the particularly your the input management, your the nitrogenous or the macronutrient phosphorus fertilizers, potash fertilizers, then you have the irrigation practices and you take the biotic factors like weed management, pest management, that is important to maintain a proper vegetative growth. Then comes for your reproductive growth, where you have the flowering development, pollinations, fertilization occurs, and there also the is very sensitive because proper management required for the transition from the vegetative to reproductive phase. So, there is a proper development of the reproductive organs. In that case, the focus is for the of course the nutrient supply and the proper water, proper nutrient supply, and is the pest and disease also, that also influence here. Then the final stage as a maturity, that is a grain mature, ripening phase where you go for the harvesting. So, here the nutrient is not so much important, here most focus is for the irrigations, water management is very important, and in addition to that the plant protection. So, with this the different phases we will discuss, we will also give a as a way for the growth phases. If you see that gives understanding how the crop growth phases takes place. This is a sigmoid growth curve, crop growth phase. So, with the duration time how the growth happens, the growth is not linear crop growth, it looks like like a S shape. So, there are you can see the crop growth phase as a any rice, wheat, the crop crops what are divided into 5 growth phases. The phase 1 we say as the lag phase. What is the lag phase? This is the time when you have sown the crop, you have the planted the crops. And why I want to explain the crop growth phases, because whenever we are going for this simulation exercise and if you give the inputs you get the outputs. Output means your biomass will be there. After the biomass then you have the grain parts production. So, here it is very essential to know how the crop growth behaves with the time with different input management, because you have to hit the optimum growth. With varying inputs the growth the quantity of the will vary, but the pattern will remain same, the growth pattern remains same. So, the initial phase is the lag phase, we can say sowing or establishment, when the crop has been seed has been sown or the crop has been transplanted, because the crop tries to establish fast, develop the root system. The crop can understand the ecosystems, what is the soil system, what is the weather here and how the root can develop. So, that is the initial stages, because when you have sown the crops, the plant takes the initial nutrient from the seedling, the germination, the plumule emerges, that takes initial nutrient from the stored material in the seed. But after that exhausted, then the crop needs the nutrient supply that comes from the soil after the root elongations. So, that root elongation, that is the establishment phase, where you will not find much growth, only this is just constant, we can say not growth. Establishment phase, the crop tries to know, to understand its ecosystem. After there is a root development, the seedling has emerged or the transplanting is done within the 10 to 15 days after transplanting or 10 days after the seedling establishment. Then there is a we can say there is a proper growth, it is a lag phase, you can say there is a peak growth starts. The growth is a very say as a log phase. Log phase means the growth rate here increases at increasing rate. Suppose today is you have to see that growth is not 10 grams per meter square. Tomorrow you can see the growth rate is the 12 grams per meter square. Day after tomorrow maybe 20 grams per meter square, 25 grams, 30 grams. So, growth rate increases at increasing rate. This is the lag phase, peak vegetative growth that happens during these periods. So, after the end of this phase, lag phase, we say as a decreasing growth rate. Decreasing growth rate means growth is there is increased biomass, but growth rate increases at decreasing rate. Growth rate increases at decreasing rate. That means, suppose before the peak growth phase, you have the growth rate suppose to 30 grams per meter square. So, in this phase, you will become next day will become the 25 grams per meter square, then it becomes 22 grams per meter square, then becomes 18 grams per meter square. That means, there is a growth, but at decreasing rate. So, this is the phase where the reproductive stage have started appearance. So, that is the phase we will discuss about the particular crop, rice crop. Then the stage 4, that comes plateau. Plateau means there is a almost there is a going to a maturity phase, you can say. The maturity phase is a grain ripening phase. So, there is a grain filling phase, you can say. So, plateau phase, there is no further increase of biomass. So, what is there is a grain filling phases, what are the biomass accumulated in the plant parts, that gets transferred to the storage organs, there is a grain filling phase, and then that is mature at the end of the phase 4. If you do not harvest here, this is the right stage to harvest. So, if you do not harvest here, make delay in harvesting, there is a leaf senescence, there is a drop, there may be over maturity, there may be loss of grain. That is what you know, say understanding of the growth phase is very essential. That talks about the input. So, in this case, if you see, if I discuss about the input management, which stage is very critical for the input management. So, very clearly you can say, when there is a peak growth here, starts from the at the end of the growth phase 1, lag phase, when there is a peak growth starts from this point, this is the very critical stage for the input management. The crop should not suffer from any type of the water stress or nutrient stress at this stage to maximize the production. So, input management is very important for this, the beginning of the phase 2, that is the beginning of the lag phase, where the growth rate starts increasing at increasing rate at the initial point, at the starting point. The crop should not suffer from any type of the water and nutrient stress. And then again when the crop is starting the flattening here, the bending the curve, this is the stage where the reproductive part starts. So, this is the stage also where you need to make sure that the crop also is supplied with sufficient amount of water and nutrients. So, these two stages are very important for any field crops for the input management. Initial stage you can supply, and this stage this is the beginning of the stage 2 and the end of the stage 2 also, or the beginning of the stage 3 is very essential for the input management, because loss of nutrients or the loss of water at this stage, that will cause the severe reduction in the crop yield. So, in modeling also, because knowing this understanding of these stages, that helps a particular stage where you can apply the water and nutrient, so that crop should not suffer. So, I will give you an example here for the particularly if you think of the crop like rice crop. So, as you discuss in the crop growth, if you see the rice crop, that has the different growth developmental phases. The developmental phases are like you see the crop growth with the time, with time, as you see the growth phases here. So, this is the lag phase, this is the time, and this is the growth. And this is in quantity, I can have the gram per meter square. As you see the stage 1, then there is a stage, this is the phase 1, phase 2, phase 3, then this is the plateau, phase 4 and phase 5. So, here you can see in rice, if this is the time where the transplanting, we say this is the tiller formation or tillering. and this phase you need to apply as a growth developmental phases. The growth we measure as a gram per meter square, these are developmental phases. So, this is what we can see, this is the flowering stage. Flowering, and this is the what we can say the rice maturity. And this stage, this is the point of post panicle initiation. Panicle initiation. What is panicle? So, I think if you are from the agricultural background, you know what is the panicle for the crop. So, if you see the rice crop, this is the root portion, and this is the you see the stem, and you have the leaves, and when there is a emergence of panicle, is that the top portion the panicle which starts here, initiation starts here, this grows along with the crop and then panicle emergence takes place. So, there is the grain formation takes here actually. You can find the grains, rice grains. The whole is known as panicle, and this starts from here. So, because this stage is very important, and this stage is very important because here the base, the tiller, because you have the rice, you know, the more tillers there is a more panicles. If you see the rice yield, how the rice, because when you go for the modeling exercise, you know what are the yield components that contributes to the yield. If you see the how do you calculate the rice yield, that can say of course gram per meter square, if you say the unit gram per meter square is equal to, that happens number of panicles per meter square into grain number per panicle into single grain weight, that is gram. You see, this is the how the three components are there for the rice yield formation. One is panicles per meter square, grains per panicles, that becomes grain number panicles, grain number per meter square. If you know single weight grain gram, then grams per meter square. This is how the crop yield, the rice yield. If you calculate rice yield, number of panicles per meter square, these are the panicles, number of grains, these are the grains per panicle, then you get the number of grains per meter square area. And if you know the single grain weight in gram, then calculate that gives the grain yield, the gram per meter square. So, if you these three components for the maximizing productions, we must see how to enhance these panicles per meter square, then how to enhance this grain number per meter square, how to enhance this single grain weight. If you increase these parameters, then we can enhance the productions. For increasing this the parameter 1 panicles per meter square. So, this stage, the beginning of this stage 2 is very crucial. If you make proper management of water nutrient at this stage, you can have more number of panicles per meter square. So, that is what this stage is very essential. So, here this needs the input management for panicles per meter square. You need the water and nutrients management at tillering. At tillering phase, you need proper water nutrient, then you can enhance panicles per meter square. Next stage comes grains per panicle. To have more number of grains per panicle, this stage the panicle initiation, this is the panicle initiation stage where panicle takes place. This stage is very important, because here this decides number of grain formations is the input management at this stage. So, here also this water and nutrient, this stage also that needs the water and nutrients management. This stage needs the optimum water nutrient management to maximize the grain number per panicule. If you take care of these two stages, then you can maximize production. The other one, single grain weight, this single grain weight is a genetic parameters, that is a crop specific, that varies from crop to crop. Some crops they have the single grain weight maybe 1000 grain maybe 20 grams, some crops may have 1000 grain maybe 30 grams. So, this is single grain weight that depends upon the crop specific parameters. So, we are not going to make any management to enhance the single grain weight. So, doing this it can enhance the crop production. That is what the stage specific, the importance of stage specific, how the stages are very important for this input management. And when you go for the modeling exercise, we must understand the crop specific, what are the critical stages and which stages we should focus on the input management, so that we can maximize the production. And that is what the importance of the growth phases. So, already I have discussed that helps in understanding of the nutrients and the nutrients management and the input the water management. By knowing these growth phases, nutrient water management, or that enhances the photosynthetic efficiency, partitioning assimilates from the storage parts like leaf to the grain parts, then that reduces loss of, because if you go for the stage specific applications, so the efficiency is much better. If you apply the crop, the nutrient the water at different stages where the crop is not very critical stages, the efficiency of the use of the inputs will be less. So, better efficiency of application that happens if I have proper understanding of the stage, growth stages, critical stages. So, pest and disease management also better, and the resource use efficiency that is higher by knowing the proper growth phase. So, with this what is the takeaways we can see, the crop growth and development that follow the distinct physiological stages and is specific in, as we discussed, each stage with specific input requirement. So, you should understand this one, the crop stages for the proper management inputs. So, understanding this space that helps the timely applications of the water and the nutrients, then you can discuss how the quantity, how much quantity applied, that is a different chapter, but that gives information, the timing, critical timing or the optimum time, the right time you can say when you can apply your inputs, then that helps with the stage specific management, like to have the good yield potentials. So, right inputs at the right time, that is what type of input will apply and what time you can apply, that can be decided based upon your the proper understanding about the growth and development phases of the crop. If I have proper understanding, that helps the input management. At the same time, for mechanization also much better, because you want to go for mechanizations. Mechanization can be very specific, you have a proper understanding of the growth and development, and then you can have mechanization, proper input management at right time, right depth. So, that is what this subject that will give you proper understanding of the growth and developmental phases of crops, and important in the input management, particularly water and nutrients. With this, I thank you all.